If you're using NX 3D CAD software and want to find interferences between moving parts or create flashy presentations or assembly instructions, you've come to the right place. I'll teach you how to animate in minutes. Finding interferences between static parts is not too complicated, but when we have moving parts, especially lots of things happening at the same time, things get awfully complicated. Let's see what Animation Designer inside of NX can do. We have the start of our machine, but before we do any interference checking and moving parts, you've got to get the right sequence of operations. Otherwise, you may get false positives. All right, so the first thing we've got to do is make this thing animate. So what we're going to do is create some rigid groups, and I'm going to create one of this frame sort of first. So this is some kind of a material moving machine. This little gripper is going to slide across, pick something up, and move it back. The biggest challenge you're going to have with assemblies is they probably weren't designed with motion in mind. For example, this sliding mechanism here really needed to have these two little sliding legs, but they were put in the wrong or a different subassembly. That's not a problem. Anything you want to move in Animation Designer, you can. So let's go ahead and start creating our rigid groups. I know this little gripper here has got to be sort of one body. Now, I know the jaws come in and out, but we could ignore that for the time being. Then we know this sort of sliding mechanism is going to go back and forth, and it's going to ride on these two linear bearings and this small plate. We also know, in fact, let's turn our rigid group color on so I can see kind of what I'm doing here. Then we want to get this whole pivot mechanism to kind of go up and down. So let's pick all of these components here, even these little guys right in here. It's probably going to be close enough right there. So it can slide up and down, and the gripper can pivot around it. And now we want to get this sort of transport mechanism. This is going to be fixed, but like I said, I don't need these two components. They're in the wrong subassembly. So what we're going to do is just simply pick them from the assembly tree and remove these from the selection. So you can kind of pick the components in a subassembly and deselect the stuff that you don't think you want. Now that that's done, that's going to act as a rigid sort of a group, and then all the rest of this stuff is going to be one big giant glob of stuff moving back and forth. Now, even though this component here was in a different subassembly, I don't care. I don't care how it was constructed. I know that has to move with it. All right, let's get a quick view of how this thing is going to move. Let's move our transporter back and forth, and that seems to be working A-OK. And this component here. Now things are going to kind of move around crazy-like because I don't have any joints on there, and now is the next step in that process. So let's first fix everything that's not going to move, which is this sort of purplish color geometry. Then we know this little guy here is going to rotate around, so we might as well add a revolute joint between these two components, spinning about that axis. Then we know this green thing is going to go up and down, so it's a slider joint for that. And we'll simply pick the geometry and a direction vector. And of course, we want this red thing to slide back and forth on the yellow thing. I love the color here because I don't need to worry about what the part names are. I don't have to worry about if I named everything properly. I just say make the green thing move or the red thing move. And last but not least, I think the yellow thing has to go back and forth. So let's slide this back and forth on this transporter mechanism or this frame rail. And that's probably going to be enough. And I think I added the fixed joints, so we should be good to go on getting this guy to move back and forth with a little bit more control. I can get this small gripper to move back and forth and around and up and down and everything by simply dragging it. Now, what we want to do is get the right motion, and that's going to require some motors. Now, you could measure from point A to point B, pretend there's a small part down there, and figure out what all the distances are, or we're going to use inverse kinematics. So the process is real simple. You pick what you want to move, where you want it to move from, and then we're going to pick our target position. In this case, I'm going to pick something that might be on this edge of this rail. Now, I know there's probably going to be a part there, and maybe we want to rotate it around to pick up something, and maybe it's not all the way touching it. So you could actually move this around kind of wherever you want it to go to pick up your actual part. And we're going to hit the go button, and just like that, it created these motors for me. Now, if you want to see what it actually did, we're going to change our option to motor color, and you can see these 4 motors here. Now we'll hit the play button, And you can see how it does everything all at the same time. Now, I know that happened real fast and at the same time. Here is where you want to spend the time getting the sequence of operations right. For example, if the plunger goes down first before it slides over, it's probably going to hit into this rail. So there's got to be a little bit of smarts built into how you want this thing to animate. So that is what we're going to use a timeline for. And you can see the events in our timeline coincide with the actual motor colors. So maybe the first thing I want to do is have the blue and the salmon color one happening at the same time. And maybe we'll let that run for like 2.5 seconds. Then we want it to plunge after we maybe give it a small dwell for just a couple seconds. And maybe at the very beginning of that, we want it to rotate around. So at the end of the plunge cycle, or halfway through the plunge cycle, it's done rotating, it's ready to pick up the part. Let's see what happens. So 2 things happen at one time. It plunges, rotates, and it does its little magic there. And we can dance our cursor back and forth to see how all of this stuff happens at the same time here. And the little small delay right there, and then it plunges, it does its magic. Now, that's the 2-stroke. To get the return stroke, we're just going to simply select everything, hit mirror, and I think I'm going to move everything out and just give it a very small dwell in there. So if we hit the play button, you'll see how it goes over and across, and then it goes down and plunges, does its magic, and returns. Now, I don't have the jaws pinching. I think you get the idea of what could be done there. The point isn't necessarily making it super correct, but getting a sequence of operations right so we can do, finally, an interference check. So let's turn everything off, and let's turn our collision on, collision detection on, and hit the play button and see what happens. And we have a small red collision on the very back of our model. If I zoom in, you can see how it's colliding with something. Don't really know what yet. These little 2 parts here are, one is sticking out probably a little bit too far. So all we need to do is just make a simple change to that and make its length a little bit less. So before we make the fix, we probably want to know how bad the interference is and when we're done. So let's go ahead and put a measurement between these 2 faces and see the before and after. So I'm going to use this little command here called a monitor. I'm going to put a measurement between this face and, if I can zoom around here, that inside face, and we'll take a measurement of that and see what that looks like. We'll plot that on a graph and just get sort of a baseline before we go any further. And as we see, when it interferes, we have a bit of a collision there, and let's use a probing tool to figure out exactly how bad it is. Right at that interference, we are about 1 millimeter or so into the part. So that's what we've got to cut this thing back by at least 1 millimeter. So let's go ahead and make that change. And what I'm going to do is back my cursor up here, and we're going to make an edit to this part. Now that we have this part as our work part, we can go to our navigator, find the feature, and make a change. And I'm just going to drag this back a little bit. I'm not going to get real picky here. And whatever it is whatever it's going to be. So we'll go back to Animation Designer, and we will run the play and see how everything is going. Of course, I'll bring up my graph again, and we can replot everything and see that there's nothing highlighting in the screen, so we know we have a clean bill of health. And let's just do a quick double check on our distance to make sure we have some kind of a positive value. Again, if this were being used for production, we of course would put a dimension on there. We would control that, get the exact distance. But we now have about a 10 millimeter gap, which is more than enough. But you get the idea on how you can use this tool to find interferences and fix them. And the whole key that made this possible is you've got to get the sequence of operations right first. And that's built on the idea that you can put whatever you want into some kind of a moving group and move them around independent of the assembly structure itself. Well, I hope this lesson helps you design better and faster. Keep watching and keep inventing. Well, that covers this week's lesson. If you learned something, give me a thumbs up. If you have a tip to share, leave a comment so my subs can learn more. Thanks for watching.